Microsoft Word document. Has anybody explored that feature? Say if I come to this and make a new Microsoft Word document, say I write the name Eduwing and I open it. This is the Microsoft Word where we all used to type, yes or no?
Yes, sir.
This
Yes, sir.
this is also now being converted into a drawing board,
Same like
and
Jamboard.
you yeah, and the good thing about is that you can change the background color and you can stretch it to infinite number of words, like it's scrolling down, down and down. Are you
Sir,
getting
can you
what I mean
repeat
to
again?
say? Yeah. Okay, let me just write it high. Suppose I have written high here. So I can take the cursor here, okay, and I can stretch my word page. Can you see the word page is increasing like anything?
Sir.
Yes.
Yes. Yeah, somebody want to ask something?
Sir, I want to
Fine.
be see that
So
the previous one, the how you make the drawing the
which drawing?
sir in the pencil. Then how you bring the pencil from the option?
Okay. Here, sorry. Here is the home. Suppose, okay, let me, I went to draw. There you might not be having draw option. If you are working in Windows 10 and above, then the draw option comes. So go to draw and these pen options come there. Please try yourself. Check it. Isn't it interesting
I
that
have,
you
sir. I'm
need not,
using that.
see, so you must be enjoying it like anything. So
Yes,
actually,
sir.
we were using Jamboard. Yeah, we were using Jamboard before, but the problem with Jamboard that it gets over after 20th Jamboard like slide, and the area available is very less. But okay, anyhow, we managed till date to the Jamboard only. But or with all due respects to all the Google products, this is a Microsoft product, so they have incorporated the drawing option such that you can enjoy the free hand writing and create your notes without even having purchasing a copy, although that has a different feeling to our generation, I understand. But say suppose if you don't have a copy and you want to create a handwritten notes, this is one of the best. What's your call? Yeah. So here we shall see today data visualization. In the MS Excel, we have already learned that what are the data visualization techniques, what were the plots, what were the graphs. Okay, can anybody name me that what were the graphs we have seen in MS Excel? Anybody?
Pivot table.
That was technique, my dear. Graphs. I am asking about graphs. So graph means x-axis and y-axis. So how may I represent my data in an x and y axis? Now is my question clear?
Hmm.
Hmm. Make a guess. Don't ask Google. Make a guess.
Sir, will we do from the insert? There will be the options. It will become.
Okay, understand. But what is the things that you start with? Suppose if you
Identical
are
value.
having so many points, say suppose you are having so many values, and these values are like this. Means I'm representing cross and dot such that these are the two categories. That's it. So don't you think that this is one of the representation of the data point in two dimension? So what do I call it? what should I name it? This is my question. Because in Python, if you don't know the name, you cannot select from the drop down window, my dear. This is not a simulation tool where you put a right click and you find number of options, you select the one and things are done. At least you need to remember the fundamental graphs and visualization plots. Haven't you remember anything from Microsoft Excel or from your recent experience of professional practices? Okay, let me give you one more hint. Say suppose I'm watching the trend analysis of a stock market, say Nifty 50, and let me draw it. What is this graph called as? Price versus time. What is this graph called as? Anybody? It's a very simple thing I'm asking right today.
Sir, this is price up down Nifty 50.
But what do we
Is
call
it
it? What do we call it?
is it is it stock marketing?
Yes, yes.
Yes. See, it's a graph of say 50, suppose 50 is an index,
Buy selling,
or
sir.
you may take, sorry, down selling.
Yeah, upside going
No.
buy.
Okay, I understand. It's upside going, it's a trend analysis, it's a
Yes,
seasonal
yes.
graph. That everything is fine. What is the fundamental name of the graph? Fundamental name. Say, suppose if I do not give you the y-axis and the x-axis, mind it, and if I ask you that, okay, this is y-axis, this is x-axis, if I draw certain lines, what do you call it? Have haven't you remembered line chart, area graphs, bar chart, histogram? Do you guys knew it or do not knew it?
Yes, no, sir. I knowing.
You knew it, yeah. Then why aren't you uttering it? Don't you think that it is a okay? Then what is this type of graph is? Any idea? We call it a scatter plot. Things are scattered in the space of either 2D or 3D, and hence the plot is between the two variables, and hence we call it scatter plot. So we have a line plot, bar plot, histogram, scatter plot. I have also shown you around, if you remember, box plot. Does anybody remember box plot? Okay, let's discuss one by one. Should I?
Yes, sir.
Yes, sir.
Thank you. Let me write them first. So one is bubble plot. One, I'm also getting recalling the things. We have a pair plot. Then we go for say heat maps. Yes, heat maps. Then I think these are the things. Okay, these are so many. One, two, three, four, five, six, seven. So most of the plots. Okay, you must be remembering pie chart. Yes or no? Pie chart, where in a given circle everything has to be divided. Everything has to be divided in a 100% corner. Say suppose this is 60%, this is 10%, this is 20%, then 10, 20 plus 10, 30, plus again 30 plus 60, 90. But it doesn't looks like that. So this overall makes up to 50%. So I make it to say 25%, then I make it to 35%. No, again a 25%. So 25%, 25%, 50%, 50 plus 50. So 20 plus 10, 30 plus again 20. So such a distribution means you have to distribute the pie charts such a way then it ends up to 100%. You don't have a choice. So what's the learning here? That whenever you are supposed to represent your data to your stakeholder or the manager, where all the components of a given data set are included and they are contributing, making a sum total of 100%, then use a pie chart. Yes or no?
Yes.
Then if I go for line chart, now I think few must be getting recalling from our Excel classes. I have given you a very good demonstration of the pie line bar charts there. So line chart says that you are connecting the dots. Say I am having a dot means dot only indicates that the value for a x-axis, it signifies the value of y-axis. So I call it x1 comma y1. This is the meaning of dot. If this is x1, so the corresponding value at y-axis is y1. And hence, so is the case with everything, every other thing. Make sense? So the process of drawing such things using Python is actually called the visualization. Can you see now? I have only connected the dots via line between the two dots. So when you have a two dots, you connect it via line. The chart which comes as a byproduct is called a line chart. Is this digestible or no? All of you.
Yes, sir.
Yes, thank you. Similarly, if I take bar chart indicates, say like this, the bars, the big bars, the smaller bars, sometimes the wider bars, sometimes the wider and taller bars. So when you have such a thing, then usually the bar charts are associated with categorical things, categorical data. Like this is the, say, the representation of the population, in terms of percentage and state wise. So say if I'm considering the four states in any region, so say I'm taking New Delhi, South Delhi, West Delhi, North Delhi, and East Delhi. So all these states will be represented by each bar, and here the population strength. Say suppose the voting done in South Delhi is, it is South Delhi, North Delhi, East Delhi, and West Delhi. So the voting percentage of the South Delhi is the highest, whereby the voting percentage of the West Delhi is the lowest. Are you getting why I have used the bar chart for such a impression where numbers doesn't make sense? So when you want to show the
Different values.
impact, must I say, yeah, you may call it a different value, but you want to show the comparative impact Okay,
Yeah, same like
comparative
cricket runs also
comparative.
before showing same like
Yeah,
that.
yeah. But in that case, mind it, your origin must start from zero. If you remember, in our
Okay.
previous classes, we have seen that, say, suppose this is indicating 38%, and this is also indicating, say, uh, 24%, suppose. And but say suppose this indicates 24%, and how come this gets, say suppose, okay, if it is 0 to 24%, then understood. But if it starts from 20% to 24%, then this portion hardly comes for 4%. It covers only 4%, whereby it is mentioning that it starts from 20%. But our
Hello? मैं क्या करूँ? करूँगा?
say suppose if the things do not start from zero, it will give you the false impression that the things are very much alike or very much akin associated bar. Yeah, anything to ask. Then similarly, we have histograms. I'm showing it to you right now because when I plot it, it will give you a frequent answers. Histograms means frequency. Histogram always represent the frequency. Frequency means whatever comes. Say suppose if I use now, say whatever comes over the y axis will represent the frequency only. So say suppose this indicates
Para
78%.
ganhar, yes, well, is bringing the blow. He said he was
Yeah,
coming. Let me call him. Let me call him to check when you. But you can call because I told you. Abia. You don't have his number.
guys, please,
All right, let me send it to
mute
you.
yourself.
Mhm.
Please mute and discuss in a personal space. Say 60%. See, these are the length of these bars, but if they represents the frequency means that, say suppose, mm, right now
Your
if I say
your
Srinivasan.
word file not showing.
Yes,
Your screen not
Deepak,
visible.
we can't see your share file.
okay, your my screen is not visible.
Yeah, not visible, sir.
Only the like
Okay,
gallery
one
link
second.
is there.
Has somebody okay, I understand that why it is being done. I heard a voice that this meeting is now getting recorded. It means the host has restarted the meeting. Wait, let me share it. I think now it is visible.
Yes,
Yes.
sir. Yes.
Okay, thank you. Okay, so I started histogram. Have you listened to it?
Yes, we heard.
Histograms means frequency. Yeah, you must have heard. Histogram means frequency. Frequency means the number of times something has occurred. So here, say suppose, uh, like out of say 70 classes, say if I say Srinivasan has joined 60% times, then I will the frequency of what's called Srinivasan would be 60% of 70. Okay, 60% of 70. So this will become 42. Are you getting what I mean to say? So the this bar will be marked as 42. Then another person joining the class will be having different frequency. So say this will be marked as 48. Then another is marked as 44. 4. Another is marked as 57. But nobody will be marked as 70. Why? Because nobody has joined my class every time. So this will represent the frequency. The histogram always represent the number of time the feature has occurred. So have you found a good enough difference between histogram and bar chart? See, they both looks alike. See here, bar chart and histograms looks alike. The only difference lies in frequency, number of times, or must I say occurrence of an item, occurrence of any entity is represented by histograms. Does it make sense?
Yes.
Yes, thank you. Similarly, if fourth one I'll take, then may I call it a box plot? I think most of you have not seen the box plot yet, but most of you must have seen it. Now, anybody remember if I draw certain thing in front of you? Have you remembered anything from this plot, guys?
Yeah, this is it's a kind of candles used in stock markets. I have seen it.
Okay, okay. No, you are correct. Actually, it seems like a candle, like whereby the stock prices starts, it goes up, it makes a high, it returns, and it stops here. So here, the body of the candle looks like this, and it represents the closing. Sorry, the low and high and low, and this represents the opening and the closing. I understand. So one of the very good insights what you have given me as answer, we call it high uh, HCLV. Okay, high close HC, high close, open and low. HCLO, sorry, CHLO, close, high, low, open. Can you see what I have written?
Yeah, right.
Yeah, yeah. You usually call it open, high, low, close, OHLC. Whenever you draw the data from the NSC or any stock market website, the OHLC value shall be downloaded. So OHLC represents where it has opened, what was the high made by it, what is the low made by it, and where did it close. So this is called. But right now I'm not talking about that, although it could represent it. But here the box plot is saying, okay, no doubt, this is the maximum value. This is the minimum value. Here represents the median, the mid value. This represents the, what should I call, uh, first quartile. First quartile. This represents the second quartile, or it is called second quartile. And this is called third quartile. Now, somebody is getting remembering anything from our last classes of machine learning? Anything from anyone? Do you remember we had discussed this? If no, then again I need to discuss. See, quartile means 25% of a given thing. So if I say, may I say this is the 25%, next 25%, another 25%, and the final 25%. Now does it make 100%?
Yes,
Yes or no?
100%.
Yes, if it is making 100%, it means the first leg, the first lower and the next leg makes 25% of the body. It means the whatever value comes from the downward towards the first bar is called first quartile. Means we have 4 quarters. Here, if you can see, even in a year, we have 4 quarters. Quarter first, then second, then third, and then fourth. First quarter starts from January to March, then April to June, then July to September, and October to December. 3 months a quarter. We call 3 months a quarter. Yes or no?
Yes, sir.
So similarly, here we make first quartile, then second quartile. At second quartile, usually median lies because half of the candle is done, 50%. And another 50%, the upper portion of the quartile actually makes to the upper portion. So we call it the third quartile, or here we usually make it to 75 till this portion. We have covered 75% of the data set. Mind it. So I think 75 percentile of the data set. Okay, I have given a difference between a percentage and percentile. If you don't remember, please Google it through. That percentage means, okay, you made 75% of the correct answer. But when you are at percentile, means you are above 75% people. You are above 75 percentage of the people. That doesn't mean that you have completed 75% of the correct answer. Out of a given answers, you are above 75% of the people. This is the meaning of percentile. So that's the reason in machine learning and Python, quartile and box plot makes a lot of impact. So hereby only we go for, if you remember, haven't we covered the outlier here? Can you remember now outliers?
Yes, sir.
Yes.
Very
So
large value.
yeah, larger value or very smaller value.
Yes,
Means,
mean data, that one.
yeah, no, actually it deviates the mean.
Yes.
Yeah, it's not a mean, it deviates the mean. That's why when, mind it, I have written median here. That's the
No.
reason whenever we go for outlier verification or outlier inclusion, we include the outlier, we never compute the mean, because it vary the mean, it shifts the mean towards the higher value or the lower value. But median is hardly getting impacted by the outlier. I think I have discussed it using a examples of George Bush or Bill Gates. If Bill Gates comes to your community, so the average income will shift towards the Bill Gates.
Yes.
So whenever the outlier calculations are done, these box plots are to be computed. Okay, this was which value? Fourth one. Now we have fifth one. What else could be there? Scatter plot. Scatter plot, I have already given you the demonstration that how the scatter plot. Whenever you have your data points represented in a two-dimensional, at least it could be three-dimensional also. Then we call it a scatter plot. Can you see? The points are simply kept where they are. That's it. And hence we have not uh, joined any point. We are only watching it as it is. Hence we call scatter plot. The plot which are only putting the points where they must be, and we are visualizing them to mentally create a decision boundary. Like if I want to create a optimal boundary out of it, so I would try such that all the points must be segregated like this. Should I? Now I have entered into the machine learning. This is the decision boundary. I have used a line chart. See, I have used a line chart inside a scatter plot. Yes or no?
Yes. X1, Y1.
Yeah. So I think you would be able to correlate now what's happening. Then we have sixth point, say, if I go for, say, heat map, suppose. Chalo. Heat map, I'll show you that how it is being looked over. Heat map actually gives you the correlation matrix, correlation amongst different features. Say you have 5 features in your data sets: feature 1, feature 2, feature 3, feature 4, feature 5. Then you want to check whether the each of the features, how do they correlate with each other. Are you getting? How are they correlating with each other? If they are very much correlating, it means we can remove any of them. Now, why to keep unnecessary repetitive features and increase the complexity of the system? Agree? So say suppose if I draw the heat map, 1, 2, 3, 4, 5, 6, suppose, then if the features are of similar nature, if the features are of similar nature, say if I take this is the feature. Arey, मिट गया? What happened? Okay. If the feature are of similar nature, why it is not happening? 1 second. Okay, let me take this color. Fine. If the features are of similar this, then say this feature value and this feature are same, then this feature is same, then this feature and this features are same. So it means the same feature will share the same color. So from the color only you can check that which features are actually similar and which features are to be reconsidered. Is my intuition understood what I am trying to say? I'll give you the demonstration also, don't worry. Yeah. Then we finally have pair plots. Pair plot we usually draw, if you remember from our past discussions of diabetic data set, there we used to draw the pair plot between various feature, and we found that the pair plot between being a diabetic and glucose, or you call it what was the name there? Do you remember the name? Glucose. There was a very technical name. I only remember this glucose. So the diabetic and the glucose, the pair plot was almost like this. It was creating maximum area out of it. So it was making the maximum impact, that from the pair plot you can check correlation between the multiple features, such that just watching the pair plot, okay, these features are very much correlated. So do you guys now able to understand that why we are studying these plots? They play a very important role, whether it's a real world, whether it's a trend analysis, whether you are doing the exploratory data analysis, or you are working over dashboards, visualization part. You have to make analysis decisions, you have to take decisions for your company. Then these graphs makes a sense to you. Else going, going through the numbers will be a burden kind of thing. Guys, please mute yourself. Please mute yourself. Okay, now I will take you through the code such that you understand the things what I'm talking about. Should I?
Yes, sir.
Yeah. Okay. As far as the what is called, say I'll go to collab. I'll open a new notebook. See, right today we are here to know that what are the libraries. Guys, please mute yourself if you are not talking directly to me. What are the libraries which are required for data visualization? We have to do it pythonically, but before that you must know the library. Does anybody any idea that what are the libraries required for data visualization? That will be very appreciated, please. Any idea? Yes, anyone? Haven't you heard about matplotlib? I've used it many times. Matplotlib.pyplot as plt. Haven't you seen it many times before in front of my screen, or in front of your screen, must I say? We have also used cborg as SNS from our past learnings of machine learning. At least I'm asking to those who have attended my machine learning class. And please run it, see any error comes. Oh, it ran well, means it understood that these are the libraries that we can import for data visualization. Okay, so here we can generate the sample data. Say there's a command called linspace, which generates the sample data. Say I have to generate the numbers from 0 to 100 with a space of 10. So I'll give 0 with space, then 100. Okay. Okay, can you guys observe a thing that a yellow line is coming? Can anybody give me a hint why this yellow line must be coming here?
There is error something.
Yeah, there is error something, so it means I need to look ahead. See, whenever you find this yellow line, just run it and see what error could be. It is saying, now I know what's the error, so let me run it for you. Let's see what error comes. It is saying no linspace is defined, means it is defined somewhere inside some module or a library. Yes, it means I have to call that library or use that library. So that library is NumPy. So I have taken a lis as np to the NumPy, and see the yellow line is gone. It's vanished. So if I'm running it, let me run it and see. It has created the number from 0 to 10. See, with from 0 to 10 with 100 equal spacing. Can you see it? With 100 equal spacing, it has done it. I think this you must have learned for the very first time, linspace. Yes or no? Guys, give me your answers. Why aren't you vocal? Why are you mum? Anything to say? Say, if I need to use these, whatever points have been created, so I can use any trigonometric function right now. So if I use for say np dot sign of input is x, and x I have already given these many points. So can you see I have done this? And now if I go for simply check what is my y, uh, let me check what is y. And mind it, these y is between 0 to -1 to +1. Why? Because it's a sinusoidal function. And how to plot it? Let's check how to plot it. So here you will use the PLT, which you have turned as a pie plot, as an alias, as a PLT. So PLT dot plot simply x comma y, x comma y, x axis and y is the function. Can you see? I have simply given data, sorry, I have simply given the numerical input and the sinusoidal has been drawn to me. Guys, is this understood or no? Am I audible even?
Yes,
Yes,
sir.
sir, audible.
Okay, okay. Is this understood how it is occurring in front of you? Sin x. You can also make it a cos x. No worries. See here. You make it a cos x, it will give a, okay, you don't go for cos x, go for tan x. Because cos x will look anyways look like that. Y equal to tan x and plotting the same. See, haven't you seen such a figure before of 10x while making in a 10th class board exam?
Yes.
Yes. So this is how you can draw anything. Okay.
Mm.
Should we move ahead?
Yes, yes.
Yes. So this is like creating a data set and using a linspace function, np.linspace function. You create a data set between a given targeted value, and you can put any trigonometric function there. Similarly, if you go for scatter plot, so say suppose if I simply write plt dot plot, plt dot, no, I won't write plot because it will again plot by its own thing. So I will write plt dot scatter because I want a scatter plot there. Say x I already have, y, if I go for y is a 10x. Let's see what happens. And if I see give the color equals to, say I want to have a red color, suppose. Let me run. Does it work or no? See how it has done. It has actually plotted a scatter plot, not a line plot, but with a blue color, sorry, red color. You may also go for, say suppose if I write here, you may also go for say any random number, say x equals to okay, do you remember that how to generate a random number in Python? Yes or no? Quick. Yes or no?
No, sir.
No. So you simply write np dot random. See, you have to use np. Np means numpy, and numpy is a module which consists of all the numerical computation. Fine. So whenever you are feeling problematic, erroneous while using any mathematical computation, always add np dot. You might get relief. So np dot random dot rand, rand, it creates random dot rand is a function which creates a random number between 0 to whatever number you give. Say if I give say 50, suppose. So this is an x-axis. You have to give it into y-axis also. Y equals to, I'll copy it, random dot rand, control C, control V. I'll run it. Now I will plot the scatter plot. Plt dot scatter x comma y. Now don't you think it makes a good sense that I'm not giving any trigonometric function? I'm only giving the set of values to the scatter, and see how beautifully it will scatter the plot. Yes or no?
Yes.
Yes. As simple as this. So you may also use, okay, I have not discussed what's called histogram. No, I've discussed histogram, but I have not discussed the distribution. If you remember the normal distribution, do you? Yes or no? Say I'm taking a variable and again creating a random variable, random dot. See, previously we were having random dot rand. Whenever you create random dot rand, it is not necessary that it creates a natural number. Okay, normalized numbers. So it will simply create the numbers between 0 to 1, 0 to 1, and you will be given an answer. Fine. But whenever you write random dot rand n, so you are calling a, what may I call, normalized random number. Let's see what is meant by normalized. 100 points. Then what's the big difference? This can only be seen when you go for histogram kind of thing. And to call a histogram, you must use the Seaborn library, not a Matplotlib. Matplotlib doesn't support histograms. So SNS dot, again you need to write HIST, hist plot, okay, you are plotting the histograms, then you give your input. See, it is asking the data. What is the data? So your data is data itself, data. If this would have been x, you must have write x here. Then it is asking to you, sorry, if it is x or y, you have given the x, then you are not giving the y. Are you giving the y here? No, you are not giving the y, you are only giving the distribution. Then there are so many what's called this parameters to be entered. So to check whether this distribution is histogram or no, let's check that how does it looks like. Say if I ask for color, color equals to, I'm giving the color of the distribution. Say if I color of the distribution, if I give green, suppose, then let's see what it does print. Oh my god, can you see?
Yes, sir.
Distribution plot. This is called distribution plot of an histogram. So now can you recall that what is the kind of distribution it looks like to you? What you have, what is you understand from the distribution from your last database studies, please? Can you see the nature of this like this? If I give one more thing here, suppose if I give KDE equals to, say, true.
Bar chart.
Yeah, it is a bar chart, but what it is representing? It is representing the count. See, count means frequency. See on the y-axis, frequency.
Yeah,
And
histogram. Yeah.
yeah, it is now representing the histogram, and you can call it a distribution plot. And the distribution looks like normal distribution. Do you remember the normal distribution? If I give you the hint here, the normal distributions looks like this x-axis. Normal distributions looks like, my dear, this, this. Here, the normal distribution mean equals to mode equals to median equals to 0. If you remember from the statistics, mean equals to median equals to mode equals to 0. And we call the first standard deviation to be distributed by 32%. So it sums out to be 68%, 64% around. And the next rest of the percentages, makes up to, say, 12%, 12.5%, 12.5%. Then it makes up to 12, 12, 24, 25%, and rest of the distribution goes for 2.5%, 2.5%. Do you remember this? Our discussions of previous. This is called normally distributed curve of anything which looks like a bell curve. Doesn't it looks like a bell curve? Guys, what do you say? Doesn't this look like a bell curve? Like a bell?
Yes.
So whenever you find a bell curve in the data distribution, mind it. So if I take you to this data distribution, whenever it looks like a bell curve, you must understand that my distribution is perfect. The data which are received either from the sensors, either from the people, or from the database, or from any source, it is very good. Have you learned it today?
Okay.
Okay. Because you must know now why you are watching it. Why? What's the insights you can draw from it?
Yes, yes.
You are not passing the time here, you are learning something. So see, this is actually a bit skewed to the left. This data, this is actually skewed to the left, but it has not turned to the right. If the data is are more towards like this, if data goes more towards right, this must have turned to normally distributed, although it is right now very slightly skewed towards left. Yes or no? Slightly,
Yes.
slightly, yes. So such distributions are to be look after. Make sense? Similarly, we have time, no? Yeah, we have time.
Yes, yes.
4 5 more minutes. Similarly, as if I go for pair plot, that's very important. So say if I have iris, I am loading the iris data set. So you can directly load by yourself. sns.load, you must write this command, load data set. So Python supports the preloaded data set with the correct notation, with the correct notation. So if you load this data set, let's see whether it is able to load it or no. It is able to load it because it was available there. So you have to now visualize the pair plot. So pair plot is again used with the help of SNS only, Seaborn. So you will write, previously you were writing SNS dot C, SNS dot hist plot. But now you need not to have hist plot. Now you need to have pair plot. So SNS dot pair plot, similar thing, but a different name. Input is iris, because here you have created this object. Here you have created this object. See, iris name object, iris comma. Okay, if I do not give anything, let's see what happens. Let's see what happens. And I have run it. SNS dot pair plot. I think the pair plot are going to be formed.
Maybe error.
Yes, see here, these are the pair plots, but these are simple pair plots which do not looks like pair plot. Yes or no? Some plots are scattered, some plots are histogram like, or they are not histogram, they are the bar charts. See here, they are the bar charts. So but they are doing a pairwise analysis. Like iris set means the flower set, the flower, sepal length, petal length, and then you have a sepal width and petal width of a flower. So iris flower data set is this very famous data set. So if I do certain changes to it, so I can create a what's called pair plot. If you remember from our discussions of uh, what is called that diabetes data set, so I have used the term hue equals to species. Hue equals to species. What is that? Where I have used this? Sorry. Okay, I've used somewhere else. Sorry. I can't use here. I have to use at a different place. Yeah, I have to use it here. SNS.pair. If I go for hue equals to species and I rerun it, let's check whether it supports. Oh my god. Can you see the beauty of Python? See here. Now, doesn't it looks like a pair plot? The pairing without indulging into a bar chart or any type of chart. Now it shows which are the things are in pair, which are the things out of the pair, which are the things having very much correlation amongst the pair, which are the things that are not related at all. Can you see? Not related at all. But there are things which are related at most. See here. So today's class was aimed to give you the introduction about that. Yeah, there are the libraries in a Python which makes things easier for you. You must know how to use them and when to use them. Make sense? Yes or no? Should I give this to you right away?
Yes, yes.
Never say no. Huh? Okay, let me writing it. Eduwing visualization. Okay, I am sharing it. I have to get it to share it, share it. Restricted link to be anyone with the link. Anyone with the link is now access is updated. I've copied the link and done. So right now I'm sharing it to Zoom. Okay, let me stop share here. Where's the chat? Here's the chat. Yeah, guy. Control V. So, yes, now you can have this. And please